Good morning. Thank you for attending this webinar. My name is KitHung Wong. I'm the product manager of Sony live production camera system based in Hong Kong. Today, I will share the updates of Sony IP remote production solution. And also we have Homa to share what is new in JPEG XS encode and decode solution offered from Nevion. Customer is facing a lot of pains in the live production workflow today that always require a full-scale independent OB production unit on site, which need a lot of engineers as a mandate for each role. Huge resource investment for direct peer-to-peer operation and expensive satellite connection. A significant amount of equipment and personnel are assigned to the location, or equipment is unable to be utilized during transportation. By working with broadcasters from across the world, Sony has developed advanced IP live production solution and has delivered more than 60 IP live studio and OB truck to customers, including the Europe Media Group, DPG Media, NEP Australia. The updated IP live lineup continues to drive efficiency and increase ROI for customer by optimizing resource sharing, creating remote production environment. By utilizing the remote production technology, less equipment and personnel need to travel to location, and transportation costs are greatly reduced. The equipment utilization rate also increasing due to it being able for allocation to other production inside the broadcast facility. Producers and technical directors now can provide real-time instruction to all operating staff in location remotely. Overseeing more remote site production needs to contend with improved overall quality. Since it minimizes the need of transportation, this technology is expected to reduce the total personnel workflow as well. Sony's cutting-edge camera system has been given IP remote production functionality. This ensures maximum compatibility with the SMPTE standard, ST2110, and more specification, and with no operational compromise to the remote site with redundant network. The recent introduction of Sony HDC ETX50 IP camera extension unit transfer current HDC series of SDI system camera into IP-enabled cameras with SMPT ST2110 interface. When using an ST2110 compatible system, you only need to bring camera head and HDC TX50 unit to the location. No need to have large-scale OB truck, and production is possible with a single size of van to cover not only HD, HDR live, but also 4K or super motion. Through its compact size, 1/3 of the standard width. The IP extension adapter offers advanced IP live, remote production, and resource sharing, which create new efficient workflow patterns for existing HDC system cameras such as 3500, 3100, 2500, 2400, even 1700. With the IP network routing function, shading of the on-site camera like colorimetry, exposure, and even lens control are being able to remotely operate from the broadcast facility. As an alternative solution, SDI I/O and RCP connection of the TX30 also allows to set up the equipment on site before establishing any IP network connectivity with telco. TX30 enables full camera control, IP stream of video, audio, return signal, intercom, and tally information of the remote cameras without CCU, support for leading IP intercom vendors including RES, KitHung, and VideoIPath, allows producers and technical director to communicate in real time with camera operator in the locations. HDCP31 support seamless integration with TX30. As advanced IP live production, no need to prepare dedicated IP converter for POV camera. It offers simple system configuration of dual live remote production camera system with just a single IP camera extension unit for field and studio application. Remote access through Web UI enable menu setting, status monitoring, log file export, and firmware update online. NMOS ISO 4 and 05 are provided as standard, and it allows operating with SNMP monitoring and Amber Plus control protocol by activation of software license. Sony's IP Live solution allows system support for connection of the camera head and CCU through traditional SMPD fiber cable. The HTC RX30 IP camera control unit extender support IP routing with TX30 between camera head and CCU for multi-studio use in order to reduce the cost of remote live production. Using in conjunction with the TX30, RX30 connects direct to the CCU that can sit remotely from camera head. Compressed signal from HTC 3500, 3100 series camera are converted to SMPTE ST2110 and stream over the IP network with no limitation on distance between camera and CCU. The use of IP live of remote production leads to reduce the production staff at the remote site and more events and shows produced on the same day by the staff that remain at the broadcast center. TX30 simplified centralized allocation of the equipment between the multiple studio, control room, and machine room, allows camera signal to route instantly over IP to other part of the facility without needing to reconnect the fiber cable or even the patch panel. Conventionally, maximum SMPT fiber cable transfer distance are restricted by its transmission limit. The adoption of IP routing is even possible to have remote production over the globe. In case of network bandwidth concern, it also supports transmission compression using the JPEG XS encode and decode solution to achieve narrow bandwidth remote production application. Let's move on to homework section. He will cover the JPEG XS solution for you. Thank you.
So this session will be focused on JPEG XS introduction and Nevion solution on JPEG XS. Okay, so this is the overview of the agenda. So first of all, we will have a brief discussion about the consideration in selecting different compression codec and also some of the compression codec overview. After that, we will going to do a very simple JPEG XS introduction and discuss about how JPEG XS can answer to the broadcast compression requirement. After that, we will introduce a use case about JPEG XS, and the final session will be talking about Nevion JPEG XS solution. When we are talking about compression codec selection, so there are three things that typically are very important. The first thing is about the bandwidth. So how much bandwidth can be reduced, or typically we are talking about compression ratio like 1 to 10, 1 to 8. And then the other things will be about the quality of the compressed video. The benchmark will be the uncompressed video, and we want the compressed video quality can be as close as the uncompressed video. And the last thing will be the latency. We don't want the compression to take a very long time to compress, okay, because it depends on what kind of application we are looking for. When we are looking at broadcast operation, so now we try to using that three direction to analyze the broadcast production requirement. So the first thing first, for production requirement, we find out that normally there will be a bidirectional communication. For example, you are sending camera signal from remote location to the headquarters, and at the same time, you also need to send the program signal back to the remote site as something like a return feed. So in this case, because there is a bidirectional communication requirement, in this kind of application, we are looking for a more symmetric codec. Symmetric codec means that the devices with similar processing power can be used at both senders and receivers. Regarding the bandwidth, in this case, because we are looking for a bidirectional communication, bandwidth reduction normally will be the second priority. And the higher priority will be on the latency side, where the timing is extremely important to make sure that the remote site and the headquarters actually can see the picture at almost the same time. So the next slide here, we are going to have a brief introduction about the compression codec. So actually, the first broadcast usable compression codec is called JPEG 2000, which was released in year 2000. So after that, there are different compression codecs that are being released. Several important ones are shown here, like H.264 or H.265. So they are great for contribution and distribution application. And of course, nowadays, there are another codec that's more famous, we call the TICO. TICO actually is developed to target the 4K application. It compress a 12G signal into a 3G bandwidth. And in 2019, we released a JPEG XS. So JPEG XS is developed based on JPEG 2000 and is more oriented for IP application. Okay, so now what is JPEG XS? So in this slide, I'm going to pinpoint some of the key features of JPEG XS. So first of all, JPEG XS has an ultra low latency. Okay, so the latency is talking about millisecond. So that means the end-to-end delay will be in sub-frame latency. And then the other thing is about the quality. The quality actually is really visually lossless when we are doing a low compression ratio like 6:1 to 8:1. But of course, JPEG XS allow you to have a flexible compression ratio up to 10:1. And the other thing is JPEG XS is very robust in terms of multi-generation performance. Actually, there's no significant degradation after 10 compression cycle. Another key thing is JPEG XS is 2110 ready. So JPEG XS is the first compression codec and the only compression codec at this moment that are combined to 2110-20 IP standard. JPEG XS is also developed for future, so besides supporting HD and 4K, it also support 8K. In this slide, so we are going to talk about how JPEG XS comparing with some of the codec that we have previously mentioned. In our broadcast case, we always start with using uncompressed video as a benchmark. So if you use uncompressed to fit into that three perspective, so we will say uncompressed codec have the lowest latency and the highest quality, but of course the bandwidth reduction is the worst. Okay. So you see here by comparing JPEG XS with the other common codec like JPEG 2000 or H.264, you will see the JPEG XS is a much better balance between the latency, video quality, and the bandwidth. Okay. Of course, JPEG XS consumes the most bandwidth when comparing with JPEG 2000 or the H.264, but on the other hand, it provides the lowest latency and the best video quality when comparing with the other two. And that makes it to be one of the best choice when you are using compression in broadcast operation. So the next slide is I'm going to introduce you one of the use case using the JPEG XS. So Roll Games actually is an American video game developer, publisher, and eSport tournament organizer based in Los Angeles, California. And actually the company is founded in September 2006, providing several games, and one of the game that's best known to everybody is this multiplayer online games called the League of Legends. So League of Legends actually becomes so famous that it has a e-sport become a global sport that attracts millions of users around the world. So at this moment, there are currently over 800 professional players on more than 100 professional esports teams around the world. So every year, the League of Legends of World Championship will be held in different places. And in 2019, actually these places will take place in Paris. Paris is the game site, but the production site actually is handled in two locations. One is in Berlin and the other one is in Los Angeles. So in this case, they require some sort of remote production solution. And that's why they are using JPEG XS in this case to provide a sub-frame latency so they can do cooperate or the distributed production at the same time. So this photo actually shows you the winner in 2019's esports game in Paris. So you see here there are multi-thousand attendants and all the esports gamers, they are competing on site, and all the signal are transmitted by using JPEG XS to Los Angeles and Germany for real-time production. So the next session will be we are going to introduce our Nevion solution. So for Nevion, we have two key solutions to support the JPEG XS. So the first thing we call is Virtuoso. Virtuoso is our multiple media function product that support both LAN and WAN situation. Our platform actually support multiple production codec like JPEG 2000, TITCO, 2110 adaptation, audio processing, and also JPEG XS. So in addition to Virtuoso, we also have another product that brings extended benefit to our customer when they are moving partially or completely into an IP environment. This one is called the VideoIPath. VideoIPath actually is Nevion orchestration and management software which allow you to connect, monitor, and control all your workflows in your production environment. So this is some of the feature highlight in Virtuoso. When you are running Virtuoso JPEG XS, so we support encoding and decoding in both HD and UHD. So we are also support a very high density of channel in a small footprints. So for example, in our 1 web unit system, we can support up to 24 HD codec or 12 codec if you are running UHD. So beside that, our platform also allow you to running in either SDI or 2110 environment or even a hybrid environment with both SDI and IP. And the most important thing is our platform is software upgradable. So that means is for existing customer, they can select JPEG 2000 solution to support their SDI system. So when they are transitioning to 2110 solution, so they can easily upgrade our system from JPEG 2000 to JPEG XS with a software upgrade. So as you see here, the Virtuoso platform actually will guarantee your investment by complying with all the future requirements. So in short, we will say Virtuoso actually will bring 3 big benefits. Okay, so first of all, it allows you to do more with less. That means it can utilize the resource very efficiently and also reducing the cost. And it is also a solution that is future-proof. So as we just mentioned, you can use it with your SDI system today and then 2110 in tomorrow. In terms of compression, you can select JPEG 2000 today and also the JPEG XS tomorrow. So as a last slide, I will want to highlight the key features of VideoIPath. So VideoIPath actually is our orchestration system for a live media network. So they can take control of the Virtuoso endpoint and the network between them. And this one is also a SDI system with intelligent pathfinding algorithm aware of bandwidth allocated. It also support multiple switch vendor and end device, and also support different network topologies such as SPI and leaf. It also support full IP or a mixed or hybrid SDI and IP environment. And it does not only manage the video flow, it also manage video, audio, data, compressed stream, and also the compressed stream in one network with a single orchestrator. Okay. And the other key things is VideoIPath will support all the existing broadcast controller, so you don't need to throw away your existing system and you can keep your existing workflow. We support almost all the third-party broadcast controller by using Mbed Plus protocol or the NS Plus protocol. And we also have a built-in panel application that can support with different kinds of new features. So that's all for our presentation, and thank you very much for listening.